Like example, compute the infiltration rate F and the accumulated infiltration capital F after 1 hour of the infiltration into the seal loam soil that initially has the effective saturation of the 30%. Assume water is poured to small but negligible depth of the surface. Okay, so solution, we can look at the above table for the seal loam soil. So we can look at this for the seal loam soil. We can bring the for the effective porosity 0.486 and suction is 16.68. Okay, so that is what we got from the above table. And the next, we find the change of moisture. We got 0.34 multiplied with the different one subtract SE, and to find the phi time delta theta. And for this equation, we have to consider this one on the left hand, capital F on the left and right hand side. So that's possible to solve this equation. So we have to take the first triangle by assume that there is only one term. If the second term is 0, so the first we got F is 0.6, and the next we just substitute this number in this side and this side, and check again. So we got the new F. The F is 1.27, and we do again, substitute 1.26 on right hand side, and what we get on the left hand side. So we for the many time we got about constant at the 3.17, and the next week substitute in this equation, we got the infiltration rate is about 1.81 centimeter per hour. Okay, next topic is spawning time. Spawning time, what is the meaning of this? Spawning time, TP, is the time when the time rainfall began and the time water began to pour on the soil surface. Okay, so this means once that the soil surface is saturated, we call the TP, spawning time. And for the Graham equation, we can use this equation to represent the spawning time period, because at the spawning time, the accumulated depth of rainfall, accumulated depth of infiltration is rainfall intensity times TP, and infiltration rate is equal to rainfall. So we can develop substitute I in here and IT here, and we can derive equation for the spawning time. Okay, so this is look like this is spawning time. Okay, on this point is mean that the rainfall is equal to the infiltration, actual infiltration. Okay, next example, compute the spawning time at the depth of the water infiltrate at the spawning time for seal loam of 30% initial effective saturation, subject to rainfall intensity, rainfall 1 centimeter and B 5 centimeter per hour. So this one should be from previous example. For the seal loam, so the same soil, we got phi times delta theta, the same in K. So if we assume that for intensive rainfall in 1 centimeter, we got spawning time about 10.5 hours, and accumulated depth is about 10.5. But if the rainfall increased to 5 centimeters per hour, spawning time is smaller to 0.17 and accumulated depth is 0.85 centimeter. Okay, and this table shows the summation of the different equation for different method for Winamp equation, for Horton equation, and Phillips equation for different condition for the potential infiltration rate, potential accumulated infiltration rate at point in time. Okay, this summation from the three equation. And the last topic is we if we know that this pond is high infiltration, the question how can we reduce the infiltration rate to save the water for the other for the community or for the agriculture, for the crop. So we can use the choice that bentonite sealer or silicone soil to seal the bottom of the pond. Or another way we can use like the sheet, rubber sheets or the plastic sheet to cover at the bottom of the pond to keep the less infiltration. Okay.